Hello students, welcome you to this video. In my last video, I taught all the results and the basics what you need for exercise 1.3. Those who have not watched, so please watch that one, then only you can understand the sums to do. So today we are going to do sums, especially how to find domain, how to find range, how to find inverse of a function. See, what is domain? What values you can give. For example, say y equal to f of x is a function. Y equal to f of x is a function. So what values you can give for x? That is the domain. The answers, the y values are called what? Range, right? For example, suppose y equal to 2x plus 3. For x, if I give 7, what is y value? 2 into 7, 14 plus 3, right? 17. So 7, that is the value you are giving, right? So that comes in domain, and the answer, that is the range, right? So here for x, what values you can give? You can give any value, right? You can give any value. So it exists. When we say a function does not exist, if the denominator is 0, we say the function does not exist, right? So something by 0, it is not defined, okay? So that values you cannot give for domain. For example, suppose you have a function f of x equal to x square minus 7x plus 6, something like this. So what is the domain if they ask? What do you say? What values you can give? You can give any value, but you cannot write any value, right? So you say the domain is R, set of real numbers, okay? Set of real numbers. But suppose if denominator, if I put some x, then when I put x equal to 0, the denominator becomes 0, right? Numerator is 6 and the denominator becomes 0. Something by 0 value does not exist, okay? So that value should be excluded. So in 10th standard you would have studied, right? Excluded values, find the excluded values. For which values the function does not exist are called what? Excluded values. So for this function, you cannot write R. From R, remove that one point. Which point you have to remove? The 0 has to be removed. Suppose if I say in the denominator is say x minus say 12, x minus 12. So denominator becomes 0. When it becomes 0? When x is equal to plus 12, right? So when x is equal to 12, the function does not exist. So what is the domain? Set of all real numbers. From that you remove what? That 12 has to be removed. Suppose in the denominator, numerator is there. In the denominator you have x minus 1 into x plus 2. It does not exist at 2 points, right? When x is equal to 1, it won't exist. And when x is equal to minus 2, it won't exist. So what is the domain? R minus 1 comma minus 2. Are you able to understand? Okay. So like this you can find the domain. And range also, you find y value. So when you find range, for example, if I take the same question, y equal to 2x plus 3. Y equal to 2x plus 3. So here, x you find from here, 2x is equal to y minus 3, or x is equal to y minus 3 by 2. It exists for any value of y, right? So denominator, it never becomes 0. So you can say the range is equal to what? R. But suppose if we have some y square plus 7, y plus 3 by y minus 2. Then it is not equal to 2. Then in that case you can say R minus 2. Okay, so like that you have to find. So we see sums in detail. See the first one, y equal to x plus 3. Now we see domain. Okay, y equal to x plus 3. What is the domain? Can you say? There is no denominator. So the function exists for all the values. So you can say the domain is equal to R, set of real numbers. For the next one, can you say? Very simple question. Domain is equal to, denominator becomes 0 when x is equal to minus 3, right? So further what you do, you put denominator equals 0, that is x plus 3 equal to 0, so x is equal to minus 3. This is the excluded value. This value has to be excluded. So domain is equal to R minus 3. See the next one, f of x equal to x square minus 5x plus 6. So you can factorize it, right? X minus 2 into x minus 3. So this exists always. There is no denominator, right? So even no need to factorize. You can say it exists always, so you can say the domain is equal to what? R. But if it comes in the denominator, then you factorize, find out the excluded points. What are the excluded points? 2 and 3. Then you can say R minus 2 and 3. But here, even no need to factorize this. Now see the same thing I written the denominator. So if you factorize, denominator is x minus 2 into x minus 3. Here the denominator becomes 0, right? When x equal to 2 and 3. So the domain is, what is domain? R minus 2 comma 3. So hope you understood this. Then one more thing I want to teach you. So this is for rational functions, right? Rational function we do like this, denominator 0. And suppose some root is there. It exists only when this part inside the root, it must be positive. It can be even 0, but it should not be negative. Root of a negative number, it is an imaginary number. Root of negative number, it is an imaginary number. You will study that in detail later. Okay. So root of a negative number, it is not, it is an imaginary number. Okay. So when root comes in the domain, you see this part must be greater than or equal to 0. Okay. So suppose it is root of x minus 3. It exists only when x minus 3 is greater than or equal to 0. So x is greater than or equal to what? 3. X is greater than or equal to 3. So what can you say the domain? Greater than or equal to 3. 3 and greater value. So this portion. Hope you understood. Last class I did all these things, right? So what is the domain here? The domain is the closed interval 3 comma infinity. Infinity you have to put open interval. Okay, so all these basic things I explained in my previous video. So that's the reason those who are not watched, please watch that also. Okay, so now you can write the answer in this form. You can write like this, or you can write using inequality. How? 3 less than or equal to x less than infinity. Hope you understood. 3 is also included. 3 less than or equal to x less than infinity. Okay, so these two things keep in your mind. So now let us do more sums in domain. Look at this question. Find the largest possible domain for the real valued function f defined by, with root we have a sum, right? So f of x equal to root of x square minus 5x plus 6. So when root is there, already I said, right? You take this part inside. This must be greater than or equal to 0. Okay, so x square minus 5x plus 6 greater than or equal to 0. If it is equal to 0, just you solve it, right? So can you factorize it? X minus 2 into x minus 3 greater than or equal to 0. Now listen, how to solve this? You have to be very careful in this one. So I'll teach this one. Listen carefully. So just I'm taking a number line. You know, in a number line, the values from minus infinity to plus infinity. When you solve this, you will get 2 points. What are the 2 points you get? X equal to 2 and x equal to 3. So plot that here. X equal to 2 and x equal to 3, right? X equal to 2 and 3 are the 2 points. So now listen. So there are 3 intervals here. What are the 3 intervals? Minus infinity to 2. That is one interval. Minus infinity to 2. Then 2 to infinity, right? 2 to infinity. Sorry, 2 to 3. Then we have what? 3 to infinity. So these are the 3 intervals you have. If 2 is included there, here you don't take 2. 2 to 3. Then 3 to infinity. Okay, so these are the 3 intervals. Now, in which intervals this condition satisfied? That means the product is what? Greater than or equal to 0. Equal to 0 you can take. So 2 and 3 can be included. 2 and 3 has to be included because greater than or equal to 0. Okay. So now you see, suppose you take a number from here. Any number you take between minus infinity, from minus infinity to 2. Don't take 2. If you take 2, the value will be 0. Right? Don't take 2. Below 2, you take a number. For example, I'm taking the number 0. I'm taking a number 0. Substitute here. You take a number 0. 0 minus 2. It is negative. 0 minus 3, that is minus 3, that also negative. You take any number, not only 0, in that particular range, you can give any number from minus infinity to 2. Even you can give minus 5. If I take minus 5, minus 5, minus 2, minus 7, it is negative. Then minus 7, minus 3, minus 10, that also negative, right? So what value you give? Suppose you give, say, minus 10, then minus 10, minus 2, minus 12, negative. Minus 10, minus 3, minus 30, negative. So negative into negative, negative into negative is what? Positive. So that means in this range, it is positive. So you may have some more doubt. I'll explain one more time. The second one I'll teach you. Please listen. Now we take the second interval. What's the second interval? Second interval is 2 to 3. So take a number between 2 and 3. You may think there is no number. No number. Is there any number between 2 and 3? Yes, there are infinite number of numbers, all decimals, right? So 2.5 I am taking. Okay, you take 2.5, you substitute in the first factor. What's the first factor? X minus 2, right? X, I'm taking 2.5, right? So if I substitute 2.5 here, 2.5 minus 2, 2.5 minus 2. So it is positive, right? So we want whether it is positive or negative. First factor is positive. In the second factor, we are giving 2.5. 2.5 minus 3. What is 2.5 minus 3? Minus 0.5. So it is negative. So positive into negative. What is positive into negative? It is negative. So second will be negative. Third will be first positive, negative, then next must be positive, right? Yes, it will come alternatively only. If you get 1, you can write the other things directly. For the examination, you can do like that. Okay. If you want, you can check it. It will be true. Now we see after 3. Already you know it should be positive, right? Let us check it. After 3, you take a number. After 3, more than 3. For example, you take 10. Okay. If I take 10 in the first one, 10 minus 2, 8, positive. I'm giving 10. So 10 minus 3, 7, positive. So positive into positive, it is what? Positive. So just to find one, you can find the alternative will change. Okay. Now you listen, which range to be taken? So it depends on the question. In the question, so what you written, x square minus 5 is what? Greater than or equal to 0, right? X square minus 5x plus 6 is greater than or equal to 0. Greater than or equal to 0 means it must be positive, right? So positives are your answers. So that two intervals are your answer. Okay, so the domain is minus infinity to 2 should be included. Because greater than or equal to 0, right? Union. In one more range, it is positive. Where? 3 to infinity. 3 to infinity. When you write infinity minus infinity, you have to always use open interval. Okay. So hope you understood. Suppose it is negative. Here root is there, so definitely it must be positive, right? Suppose it is negative means you take the negative part. What is the negative part? The middle one, the 2 to 3. So in that case, you have to give that interval, okay? Less than 0 means open interval 2 to 3. Less than or equal to 0 means closed interval 2 to 3, okay? So like that you write. So we'll do more sums so you can understand better, okay? So later you can watch this again, you can understand. Now please look at the next question. Find the domain of f of x equal to 1 by 1 minus 2 cos x. Now we have to see this function exists for which values. This is rational, right? Numerator, denominator. Whenever denominator is there, you find out what are the values to be excluded. For that, you put denominator equal 0, you will get the excluded values. So the domain is equal to r minus that excluded values. Are you able to understand? Yes, we did some questions, right? So now let us see. So these are very important questions. These type questions, they'll ask for domain range. You can expect a question. Okay, so prepare well this one. So here, now you put denominator equal 0 to find excluded values. Okay, put denominator equal to 0. For what? To find excluded values. So what is the denominator? 1 minus 2 cos x equal to 0. This is a trigonometric equation, right? So how to solve a trigonometric equation? In the previous video I explained, right? Some of the formula I asked you to remember. So that only I'm going to use it now. So please listen. So I want to find x from here. So you know trigonometric equation has infinite number of solutions. So 1 equal to 2 cos x. So cos x equal to 1 by 2. Cos x equal to 1 by 2. I have given two set of results. Hope you are remembering. In one set, the right side value is 0. Sin theta equals 0. Cos theta equal to 0. Tan theta equals 0. A set of solutions given. Another one, the right side is not 0. Some number that can be written in terms of sin or cos or tan. Sin theta equal to sin alpha. Cos theta equal to cos alpha. Tan theta equal to tan alpha. For that also we have set of formula, right? So here left side is cos x. So right side also you have converted into cos. Because left side is cos, right? So cos x equal to right side also you write cos of some angle. You know half can be written as sin 30 also. Sin 30 also half only. Cos 60 also half. We prefer cos. Why? Because the left side is what? Cos. Suppose the left side is sin, right side also you change into sin. Okay. So left side is cos x. So the right side 1 by 2 can be written as 1 by 2 is equal to cos what? 60. 60 means pi by 3. 60 means pi by 3. So that also remember 0, you write 0 only. Pi means 180. Okay. Pi radians equal to 180 degree. So 0 you write 0 only. 30 you write pi by 6. When you have a doubt, just you put pi equal to what? 180. 180 by 6 you will get 30. 45 pi by 4. 180 by 4 you will get it. So 60 is pi by 3. 90 is pi by 2. So okay, we write in terms of pi here. So radian measure. So now this is of the type, listen, cos theta equal to cos alpha. I given a formula. Cos theta equal to cos alpha. The formula is theta is equal to 2n pi plus or minus alpha. This is the formula. And this is our alpha. What is alpha here? Pi by 3. So theta, instead of theta, what do you have here? X. So you can say x is equal to, the solution is x is equal to 2n pi plus or minus alpha, alpha value pi by 3. This is not your final answer. This is the excluded value, right? We put denominator 0, you got this result. And when you write the domain, r minus this value. Okay, so this value has to be excluded. Okay, so you can say therefore domain equal to r minus 2n pi plus or minus what? Pi by 3, where n belongs to z, set of integers. So same type, I'll teach another question. Find the domain of 1 by 1 minus 2 sin x. So this is the given function, f of x equal to 1 by 1 minus 2 sin x. Similar question, right? So to find the domain, you have to remove the excluded values. So to find excluded value, you put denominator equal to 0. So for excluded values, put 1 minus 2 sin x equal to 0. 1 minus 2 sin x equal to 0. So from here you solve for x, another trigonometric equation, right? So 1 equal to 2 sin x, or sin x equal to 1 by 2. Sin x equal to 1 by 2. Since left side is sin, so now you know right side 1 by 2 means sin 30, right? 30 can be written as pi by 6. Yes, so you can write it as sin pi by 6. Now this is of the type sin theta equal to sin alpha. Alpha is pi by 6. So you know the solution. The formula you have to study, no other way. So theta equal to, instead of theta you have x. The formula n pi plus minus 1 raised to n into alpha, alpha value pi by 6. Okay, so that formula we are using here. And this is the value has to be excluded. So you can say therefore domain equal to r minus n pi plus minus 1 raised to n into pi by 6, where n belongs to z. So it's very simple only. So once you understood, you can do it very easily. Okay, now let us go for another question. Find the largest possible domain. So again, I'm teaching domain. What are the possible questions I'll teach? So you should not have any doubt in domain. Let them give any question, you can do that. Okay, so find the largest possible domain for the real valued function given by f of x equal to root of 9 minus x square divided by root of x square minus 1. Okay, now please listen carefully. Root is there, denominator also there, right? We did sums using root, also we did sum using denominator also explained. But here is a combination of both. Okay, now please listen here. Since root is there, what you have to check? Inside the root, it must be positive, greater than or equal to 0, right? So here the numerator is root of 9 minus x square and the denominator is root of x square minus 1. So what are the values to be excluded? So here better we do the inside the root, it must be positive. That is the domain, right? So what is the term inside the root in the numerator? 9 minus x square, right? So 9 minus x square must be greater than or equal to 0. For the other one, denominator inside the root, what is that? X square minus 1. Please listen very carefully. One of the very important step I am going to tell now. X square minus 1 is there, right? So what I am going to write here, it must be positive, right? X square minus 1 greater than 0. Here I have written greater than or equal to. Here I am writing only greater. In both the cases, root is there. Can you tell me why it is that? If you are able to say yes, you understood properly everything. Some of you have got the answer. Because that is in the denominator. Denominator, it should not be 0 also, right? Numerator can be 0. 0 by a number is what? 0. So numerator can be 0. That is why the term inside the root, it is positive, means it is greater than or equal to 0 you can take. But in the denominator, if you take greater than or equal to 0, if you take equal to 0, denominator root of 0 is 0 only. Something by 0 it is not defined. So since root is in the denominator, for that one, the term inside the square root must be only greater than 0. You cannot take greater than or equal to 0. Okay, it's a small difference, but it is very careful in this one. Okay, so now we solve both. So second one you can solve very easily. You can, from here directly you can find out, right? X square minus 1 greater than 0. So you can factorize it. X plus 1 into x minus 1. X plus 1 into x minus 1 is what? Greater than 0. So what can you say now? Greater than means lies outside. Greater than means lies outside. Less than means lies inside, right? So here greater than, so lies outside plus 1 and minus 1. X lies outside 1 and minus 1. So when you draw the graph for this, you draw a number line. So it varies from minus infinity to plus infinity. Outside 1 and minus 1. Minus 1 is in the left side, 1 is in the right side. Outside, so you cannot take that one, right? So that point also you should not take because only greater than. So outside means this portion and this portion. Don't darken the circle because that point is not included. Only greater than 0. Greater than or equal to 0 means you have to darken that points also. Okay, so this is the answer for this. Now see the other one, the numerator. 9 minus x square greater than or equal to 0. I want to solve it. So first x square term I want positive. So change the sign throughout. Change the sign throughout. In inequality you studied, right? Inequality reverses in two cases. When you multiply by a negative number, the inequality reverses. When you take reciprocal also, the inequality reverses. Here I am going to multiply by minus 1. So you will get x square minus 9 less than or equal to 0. When you change the sign, it becomes 0 only. Can be factorized x plus 3 into x minus 3. Less than or equal to 0. Less than means inside. Less than means what? Inside. So what do you have to say here? X lies inside minus 3 and plus 3. So for this also we draw a number line. So this is a number line I am taking, say minus infinity to plus infinity. So which points you have to mark? Minus 3. Minus 3 is in the left side, minus 3 and plus 3. Plus 3 is here. Less than inside. Inside means this portion. Can you take minus 3 and plus 3? Less than or equal to is there, no? So even that minus 3 plus 3 also you can take. Now please listen. If only the numerator is there, this is the domain, minus 3 to plus 3, closed interval. Only the denominator means what we have written, minus infinity to minus 1, union 1 to infinity. But it is a combination of both. So you have to combine both the domains, combine both the answers, and you have to find out the common portion, the common for both. So that will be your solution. Okay, so now, I'm going to draw another number line in which we take both the domains. So we take this, say, minus infinity to plus infinity. Say minus 1 is somewhere here, minus 1, minus 3. Minus 3 is here, 1 is here, and 3 also. Okay, number line. So positions you give correctly. Now listen, the first one, the numerator, minus 3 to plus 3, minus 3 to plus 3, minus 3 to plus 3. So this portion. And minus 3 and 3 also included, right? So this is for the numerator. For the denominator, minus 1 to minus infinity, minus 1. Minus 1 is not included. Minus 1 is not included. Minus 1's left side. Minus 1's left side. So this portion. And 1, the right of 1. 1 is not included. It's right side. 1 is not included. It's right side. So now you see which portion is common. This portion is common in both. This is also common, right? Only these two are common. So now the domain is, now please listen very carefully, minus 3 to minus 1. Which interval you have to give? That also important. Minus 3 is included, right? Minus 3 is included, but minus 1 is not included. So open interval, closed interval, do it carefully. Union, in the other side, 1 is not included. So open interval 1 up to 3. 3 is included. Okay, so this is the domain, combination of both. So it's one of the very important questions. Hope you understood. So this is how you have to give the answer. Okay, now let's go for the next question, similar question. So f of x equal to root of 4 minus x square by root of x square minus 9. Similar question, numerator root, denominator root. We have to find what? Domain. So, you know, already we did one sum, so I think we can go a little fast, right? So for numerator, you take the term inside the root, 4 minus x square is greater than 0 or greater than or equal to 0. It is the numerator, so greater than or equal to 0. Denominator, the term inside the square root, x square minus 9, greater than 0 only. You cannot take equal. So here, first one, you change the sign, x square minus 4 less than or equal to 0. When you change the sign, you have to reverse the inequality. So x plus 2 into x minus 2 less than or equal to 0. Inside, right? X lies inside what? Minus 2 and plus 2. X lies inside minus 2 and plus 2. So now let us draw a number line for this. So minus infinity to plus infinity, right? It lies between minus 2. So minus 2 is somewhere here, plus 2 is somewhere here. So inside, so this portion and the end points also you can take. Okay, so that you can shade that minus 2 and plus 2 also. Now, you solve the other one, x square minus 9 greater than 0. Factorize it, x plus 3 into x minus 3 greater than 0. Greater than 0 means lies outside. So x lies outside minus 3 and plus 3. So now we draw a number line for this. Say minus infinity to plus infinity. So you plot that points minus 3. So minus 3 is here and plus 3 is here. Outside, so this portion, right? Outside of minus 3 and plus 3, the points are not included. So you don't shade, don't darken that circles, okay? So now we have to find the combined portion, right? Combined portion of both. So I'm taking another diagram, say minus infinity to plus infinity. So all the points first you plot. So minus 2, minus 3 will be here, right? Then here 2, here 3. Okay, the number line, the order you know. So once condition is, it lies between minus 2 and plus 2. Minus 2 is included, 2 also included, between that, so this portion. Okay, that is for numerator. For the denominator, minus 3 is left side, minus 3 is not included, minus 3 is left side, minus 3 is left side, and another one is what? 3 is right side, 3 is not included, 3 is right side. Which portion is common in both? What is common? Nothing is common, right? Okay, so what is your answer? Largest possible domain. Largest possible domain is empty set. Okay, because nothing is common here. So your answer is what? Empty set. So hope you understood thoroughly the domain. So now just I want to take one or two sums in range also. Okay. So range, already explained what it is. Just one result you remember mainly here. Sine and cos. Sine theta and cos theta lies between what? Minus 1 and plus 1. That you remember. Find the range of the function f of x equal to. So f of x equal to 1 by 1 minus 3 cos x. Questions look similar. So there also we had sums like this, right? But you read the question very carefully whether they asked what domain or range. If they ask domain, see that when it becomes 0, you put denominator 0, find the excluded value, you write r minus excluded value. That is for domain. But here range, this fx must lie between what type of values it can take. Fx as a whole, not x value, fx value, that is y value. What values y can take? Okay, that's what we are here. Instead of y, it is fx. So here, since it is cos, you start with cos. So how you have to get the answer? You know, f of x lies between which two numbers, or in what range f of x exists. Okay, so that's what we have to find here. So here, what I'm going to do, since it is cos, so we start with cos. You know, cos x lies between minus 1 and plus 1, right? So minus 1 less than or equal to minus 1 less than or equal to cos x less than or equal to plus 1. If it is sine, you write sine x. Sine also same condition, lies between minus 1 and plus 1. This is to find range, okay? So now, here I have cos x, right? So in this place, I want this full fx. So step by step we take. Cos x, you got it. Now with that cos x, what do you have? Minus 3. So that cos x you multiply by minus 3. So next step, what I'm going to do, multiply by minus 3 throughout. Every time I'm going to multiply by minus 3. When you multiply by a negative number, you know the inequality reverses, right? And why we are multiplying everything you must know. That's why I said cos x. With that we have minus 3. So we multiply by minus 3. So minus 1 into minus 3, it is plus 3. Greater than or equal to, inequality reverses, right? So multiply by minus 3 cos x. Greater than or equal to minus 3 into 1 minus 3. Okay, now please listen. Minus 3 cos x, you got it. Now, another plus 1 is there, right? So to get the denominator, you add one more. So the next step, what I'm going to do, adding 1. No need to mug up anything. Just see the question, you write step by step. So adding 1. So every time add 1, when you add a positive number or even you add a negative number, it won't, there is no change in the inequality. Okay, add 1 with every term. So 3 plus 1, 4. Greater than or equal to add 1, you will get 1 minus 3 cos x. Greater than or equal to add 1, you will get minus 2, right? So 1 minus 3 cos x, you got it. 1 minus 3 cos x, you got it. Our aim is to get that fx. So what is fx? 1 by. So next step, I have to take reciprocal, right? You take reciprocal. So taking reciprocal. when you take reciprocal, you know again inequality reverses, right? So take reciprocal of 4, 1 by 4. The greater than or equal to become less than or equal to. Take reciprocal 1 by 1 minus 3 cos x less than or equal to minus 2, right? So inequality reverses, or you take reciprocal, so minus 1 by 2, minus 1 by 2. Now you got that fx, right? So this part, this is our fx, the question, right? So now what, one more step if you want, you can write 1 by 4 less than or equal to fx less than or equal to minus 1 by 2. Now I'm going to split into 2. So take this part separately, take this separately and this separately, okay? So when I take this one, 1 by 4 is less than or equal to fx. If you reverse it, fx is greater than or equal to 1 by 4. Fx is greater than or equal to 1 by 4. And the another one is fx is less than or equal to minus 1 by 2, right? So these are the two areas you are getting. One is fx is greater than or equal to 1 by 4. So if you draw a number line, so f of x is greater than or equal to 1 by 4. 1 by 4, say I'm taking a 1 by 4 here. 1 by 4 greater than or equal to 1 by 4. Okay, 1 by 4 is also included, and the greater values, it goes up to infinity, right? Another one, fx is less than or equal to minus 1 by 2. Minus 1 by 2 will be in the left side, right? So minus 1 by 2 less than or equal to, so that point is also included. Less than or equal to, so the left side value fully, it goes up to minus infinity. So these are, here don't take the common value. So these are the two areas you are getting. So you can say the range is equal to the union of these two. What's the first interval? Minus infinity comma minus 1 by 2 union 1 by 4 comma infinity. You know why we are using closed interval, that point is included, right? So I'll take one more sum of the same type so you can understand better. Look at the next question. This, first you read this, that's very important. Find the range. Sometimes when they ask range, students write the answer for domain. Okay, so same question can be asked for both. So read the question very carefully. So now listen, since here also you have cos. Cos or sine, you know, lies between minus 1 and plus 1. So you start like this, minus 1 less than or equal to cos x less than or equal to 1. Now you know the steps. What's our next step? Cos x we have. With cos x what do you have? 2. So you multiply by 2. Multiply every term by 2. When you multiply by positive number, 2 is positive. So there is no change in inequality. Multiply by 2, minus 2 less than or equal to 2 cos x less than or equal to 2. Okay, my 2 cos x, you got it. Now denominator we have a minus 1. So subtracting 1, next step subtracting 1. If you want you can write subtracting 1 with every term. So minus 2 minus 1, what is that? Minus 3 less than or equal to 2 cos x minus 1 less than or equal to, when you subtract 1 you are getting 1. So you are subtracting 1, there is no change in inequality. But next you want, so you got this 2 cos x minus 1. Now I want 1 by. So you take reciprocal in the next step, right? Taking reciprocals. So minus 1 by 3 greater than or equal to 1 by 2 cos x minus 1 greater than or equal to 1. Reciprocal is 1 by 1, it is 1 only. Inequality reverses, because when you take reciprocal, inequality reverses. That is minus 1 by 3 greater than or equal to fx, because this is our fx, right? Fx greater than or equal to 1. So now we split into 2. This part, minus 1 by 3 greater than or equal to f of x. If you reverse and write, fx is less than or equal to minus 1 by 2. And the another one is this part, f of x is greater than or equal to 1. So now in a number line, because once you draw the number line, then writing inequality or as a set, it will be easy for you. Okay, so now you plot these points, minus 1 by 2. Minus 1 by 2 is somewhere here. Minus 1 by 2. Fx is less than or equal to minus 1 by 2. So minus 1 by 2 and lesser values. Minus 1 by 2 and lesser values. So minus 1 by 2 is also there. So darken the circle. And the second condition, second one says fx is greater than or equal to 1. 1 is the right side. 1 and greater values. 1 and its right side. It goes up to infinity. So you can say the range equal to range is. So take the union of both the intervals. The first one is minus infinity comma minus 1 by 2 closed interval union. Then again 1 is included, so closed interval 1 comma infinity. Okay, so like this you can find domain and range. Hope you understood all these things. In my next video I'll teach composition of functions and other things.